Good afternoon. I'm Mark Moselle. This is Drew Mathrola, and it's our pleasure to be here today to talk about our journey with big data at Geisinger Health System. Geisinger Health System is located in Pennsylvania. We're an integrated health services organization, which means in addition to providing direct clinical care through our hospitals and clinics, we also have an insurance plan with about 500,000 members. We're known for our innovation. President Obama actually mentioned Geisinger at a State of the Union speech that he gave a couple of years ago. We do about 100,000 surgeries a year, or 75,000 surgeries a year, and about 100,000 admissions. We have 12 hospital campuses and growing. So for the folks that are in the healthcare industry, there's a lot of merging and acquisition occurring, and we've been part of that as well. So I want to talk a little bit about our data journey, if you will. From an innovative standpoint, we were one of the first adopters of an electronic health record, and that was in 1996. We went with Epic, and as you can imagine, having clinical data as well as claims data, we had a lot of data. And the thought was, what's the best way to take advantage of that data and use it for insight? So about 2006, there was a group that was put together to create what's known as CDIS, and that's a clinical decision intelligence system that they named it. And we started in 2006, and in 2008, we had a system stood up running on DB2. And over time, we converted that to SQL Server, and then we went to Teradata, and that was in 2012. And we actually run on Teradata today. We have a EDW, and you can see towards the bottom there, we have probably about 3,000 consumers of the data, and we have maybe 800 or so developers. And they're using either SQL that they're generating themselves, or they're using business objects. And so after that, we decided to move towards HADOOP, and I'll talk about the reasons for that in a moment. So this is a pretty basic slide, but initially the driving force for a data warehouse was just to get all the data in one place and to join that if we could and allow for self-service. So as I mentioned, we have business objects and also SQL tools that folks can use to write their own SQL. One other thing I can mention here as well is that we have a wide range of users on the system, from analysts to clinicians to data scientists. So it's always a consideration on our part to try to give an environment that folks can find value in no matter what their background is. So what kind of issues did we have? And I'm not going to read all those balloons there, but in general, we had a self-service environment, but with a lot of gaps. So training, people had training needs. All of the source system data that we brought in didn't have data dictionaries, and we, from an IT perspective, we didn't have that information. There was also other challenges with the data. Some of the data we weren't able to join. Some of it had disparate data types. There was data quality issues. So I'm sure any folks that have a data warehouse, you probably see the same things. So this is just some of the things that we've learned over the years. But in general, you need good quality, documented data that's timely and consistent. And that's what the users want. They want their queries to run the same amount of time every day. They want to get the right results. They want to have confidence in the data. And that's what we strive to do. So I talked about replacing the EDW or CDIS, and our plan is to actually replace it with what's known as a unified data architecture. And Hadoop plays a large role in that. We have a couple of EHR systems that have their own analytic component, and so those would be part of this unified data architecture as well. So for example, if we have some folks that are really just interested in particular clinical data that's already in our EHR, they can certainly use the analytics tools that come with that EHR. But if they're looking to join other data or do some more advanced analytics, they're probably going to come to Hadoop. So why are we looking to replace the EDW with Hadoop? And I'll just say that a lot of folks are supplementing their EDW with Hadoop, and we're going to go past that. We're going to really try to replace completely our EDW. We have end of life on our hardware at the conclusion of 2018. So we're trying to move everything off and get to a point where we're not using it. So a big factor that motivated us was cost. Using commodity hardware with Hadoop, the storage is about 10% of what we were paying on our EDW. And we run an appliance, so it's a hardware and software solution. Ingestion of data was one of the challenges that we had. So probably when we stood up the data warehouse the first time, we had some core data sets, maybe 5 or 6 data, so billing, claims, clinical. But we found that there were pockets of data throughout the organization, cardiology, maybe other specific, neurology, urology. Everybody had kind of their own system that they kept some supplemental data in that went along with the EHR. And of course, our users wanted to bring that in as well. And in our EHR system, it would take us a couple of months to bring new data sources in. We had to model it, we had to map it, we had to profile it. There was a lot of work that we had to do, and really, we started to queue those requests up, and we were tight on resources, and that was always a challenge for us. So Hadoop allows for what is known as late binding. So basically, you just drop the data in at the HDFS layer, and we built a custom data ingestion pipeline, which Drew's going to talk about. But you have a configuration file, and you bring the data in. And later on, you figure out what you're going to do with it, and you might have multiple ways to access that data. But in our EDW, we had to figure all that out ahead of time. And a lot of times the use case would change, requirements would change, and we'd have to go back and redo things. So multiple views of the data. As I mentioned, we have a wide range of analysts that are using the data. So we have different opportunities and different ways of looking at that same data that meets their needs, including temporal modeled data. And unstructured and semi-structured data. So in our EDW, it's mostly structured data, discrete fields. We had some text fields and things, but users couldn't really query against them. We have, for example, notes that clinicians take during an encounter with a patient. And just to do a simple query could take like a half hour. And if you wanted to change it, it took a lot of time to change it. So it wasn't really useful for structured, unstructured, and semi-structured data. So this is just kind of an overall look at what we do. So there's some internal data sources there at the bottom, certainly not all of them. And an example of an external data source that we would bring in would be a health information exchange. And we have a number of zones that Drew will go into, but you can see some raw, refined, current, integrated, reference. And then there's services that our group provides to the organization, ingesting data, integrating the data, standardizing it, normalizing it. And once the data is available, how do people access it? So we've stood up Tableau for dashboarding. The query tool that we've been using initially was SQL Workbench. We use dbeaver. We've looked at some of the open source tools as well. And we use a product called Solar. In a lot of the presentations that we've been here this week, we hear more about Elasticsearch, but they're very similar. It indexes the data and allows for quick retrieval. So if you've used Netflix or something like that, you're using Elasticsearch or Solar in the background. So this was kind of a marketing thing, but they talk about the 3 V's of big data, and we actually came up with 5. It's kind of a good way to look at some of the interesting points about our data. So we have a project called MyCode, and we're inviting patients to submit their samples for genome and sequencing. And I just got an email yesterday that we passed 150,000 patients participating in that. Clinical notes, we have, I think that's low, we have over 200 million clinical notes from providers. The Hadoop cluster that we have stood up is 30 nodes. That equates to 600 terabytes of storage. And in the upper right is our electronic health record. And here's another example of what we were able to do. In our CEDIS environment, we could only pull in about 1,200 tables. And we started with the base tables that everyone uses. And then we were getting requests every week to add tables. And so we had a whole release process set up. But with Hadoop, because of the cheap commodity storage, we went to the source system and said, just give us everything. And we don't have to come back and get more later. So that talks about the volume of data. So velocity of data, I talked a little bit about speed of ingestion and late binding. So now with Hadoop, we're able to load data in days versus months. So brand new source system. Within a couple of days, we can load that in HDFS. Real-time capabilities, we did a little bit of real-time work in CEDIS, but we have plans to expand that quite a bit. We've already started ingesting some logs, system logs from the organization, and one of the next things we're looking at is medical devices. And the upper right, it's a real quick search to go through when you're using Solar. So variety, anybody that's in healthcare, there's all kinds of different data sources out there, right? Unstructured data, and there's different zones to access it. And veracity. So, what's how can we make sure that the data is valid? What are the characteristics of the data? So we single source of truth, try to pull the data as close to the source system as possible. It's not always possible, but pull it as close as you can. We utilize encryption because of HIPAA standards. We masked PHI, so protected health information in our development environment. And we make sure that folks have the right access when they're accessing the data. And value, open source, obviously, there's a lot of benefits from a cost perspective there. Also, you can try some of the new software that's available before you actually have to pay for it. NLP is natural language processing. Drew's going to talk about that, but that allows us to get even more value from our text and unstructured data. And in the upper right there gives a little bit of the idea of the cost savings. So in our EDW environment, it's about $500,000 to add 10 terabytes of data capacity, and we're doing it for about $20,000 with commodity hardware. So what are some of the things that we've learned getting everything loaded into Hadoop? I talked about ROI a bit, change. We're still working with that. Anytime you go to a new system, there's nuances with SQL, and users aren't maybe the most driven to move to the new platform. You have to prod them a little bit. But Teradata has performed well for us. It still performs well. So we spent a lot of time tuning that system and getting it working well, so users are pretty happy there. I talked about loading everything. So I can remember when a doctor would come to us and say, hey, I need 10 tables loaded in CEDIS from this source system. And we'd say, well, how big are the tables? Because we're not sure we have enough room for everything. Now with Hadoop, we just, if he needs 5 tables and the source system has 100, we're taking all 100. Self-service, I think, is, of course, very important. You want to have the analysts develop their skill set and be able to answer their own questions so that we can do some of the other work. From an adoption standpoint, what we found is that you have to have some early wins. And one of the first things we did was we took that Solar search, Elasticsearch, and we set it up on our clinical notes. And I was one of the people presenting at our physician leadership group, and we had 200 million notes. I took some input from someone in the group to give me a word to search for, and I said, now watch it, it's going to come up pretty quick, and it came up in less than a second, and the one doc said, I don't believe it. So they were just blown away by it. So that kind of got people talking about Hadoop, which I think was very important. And then we went and got some good use cases. So there was a couple of partners that we wound up working with that had ideas that they had been wanting to implement for years. And so we sat down with them and we said, okay, let's see if we can do this, because if we can do some of these things, then that'll really show the value of Hadoop. And Drew's going to talk about those in detail, but we were able to do that. And then visualization, I think, is very important. Data by itself is pretty plain and boring. Not to us, but to some folks. And if you have a good visualization tool that can show the data, that gets people energized and gets people part of the process. Also, we found that a lot of folks that need an analytic solution, they don't know what they really want. And they don't know what your capabilities are. So what we would normally do is get as much requirements as we could, put a dashboard on top, and then we do the rest ourselves. We take our best shot at it. And it may be totally off base or not. But when we showed it to the folks, they said, wow, that's cool. Is there any way you can do this? And can we add this to it? And then that got the discussion going, and then they were on board. So I think a good visualization tool is very important. Excuse me. Data zones, we'll talk a little bit more about that. From a capacity standpoint, we're looking potentially to move our development environment to the cloud. We have some regulatory and compliance hoops to jump through to get to that point, but we're not there yet. I would add one thing that, we started with 5 nodes for Hadoop. We were quickly to 10, and now we're at 30. So when you get to that point, you're moving maybe a little quicker than you planned. So if you have a range of nodes or capacity that you're looking at, maybe go towards the high end when you're planning your cluster. Just one little note on this. When I was on the plane coming in here, this is our first summit conference. And even though we've been working with Hadoop for a year and a half or so, we didn't know if we were minor league or major league. And so it was going to be interesting talking to folks, and we're looking forward to learning a lot. And I started talking to a couple people early on in the first couple days, and they found out that, we were using 2.6 and they weren't on 2.6 yet. And we were using LLAP and they weren't using LLAP. So I thought, well, we're doing pretty well. And then somebody would say, well, we have over 1,000 nodes. How many do you have? And I'd say 30. But hey, 30 nodes is right for us right now, and it works. So I talked a little bit about the size of our environment, 600 terabytes versus 30 terabytes. There's some of the source system data. So we took everything from the EDW and we put that in Hadoop, and then we added a bunch more. So for example, lab system data, that was something that was going to be a constraint in our EDW, and we were able to bring that into Hadoop. Excuse me. Just out of curiosity, is there anybody that's using LLAP or testing with it? Okay. So that's probably one of the things that we were most eager about in Tech Preview was LLAP. We're always looking to improve our Hive performance and get it in the ballpark of Teradata. We had it running okay, but we reached out to Hortonworks and got their professional services involved. And I would definitely recommend that. Some of their recommendations on the left there is what we went with. So of the 30 nodes on the cluster, we're running LLAP on 10 nodes. We're using 40% of the available Yarn resources and allocating that to LLAP. And we have the cache set at 100 gigabytes. And I mentioned we were trying to get in the neighborhood of Teradata. So if Teradata ran in a minute, if we could get it around 2 minutes or so, we were pretty happy. But after doing this tuning, we had 22 queries that we used as base queries. And these were real-world queries. They were either generated from user SQL directly, or they came from business objects. And we were able to get 20 of those 22 queries running better than Teradata. So we were thrilled with that. And we talked to Hortonworks earlier in the week, and they said, what about those other 2? Can we look at those in a little more detail? So, but we've been very happy with the LLAP performance. We just pushed that into production. So our users are starting to get a taste of that. They can use Hive 1.2 or LLAP. So the folks are just starting to get their feet wet with LLAP, but we found that it works quite well. And now I'm going to turn it over to Drew. Drew's going to talk a little bit about the data ingestion pipeline and some of the specific use cases that we're able to do with Hadoop.
Right. Thank you, Mark. So I think, in a traditional EDW environment, I think, our basic use case was to get data from various source systems and load it into our traditional data warehouse. The biggest problem with that was, the amount of time it would take for us to create customized code for bringing each and every data sources or each and every table within a source into our traditional EDW system. The other challenge that we had is, the maintenance that it would be since we were writing customized codes. And the third challenge was mainly, the amount of time it would still take to load from one source to the other. So I mean, one of the examples is the Epic Data, which is our EMR system. And, we have the Epic Cache, which is a mainframe-based system. And that would actually generate ext files, which would get loaded into the Epic Clarity system, which is Oracle-based. And then that would be copied over to our EDW using one of the replication tools available in the market. I think the biggest problem was it would take close to 7 to 8 hours to actually do this through the night. So, we just couldn't do each and every table that was available in the EMR system. And we had to go with about 1,100 odd tables or something. So with Hadoop, what we did is, since, we wanted to save time on, doing this pretty quick, we made sure that instead of taking the data from their Clarity system and loading it into Hadoop, we directly went to Cache. We just took all the files that were available through Cache, which actually loaded Clarity, and we just dumped it into Hadoop. All right, yeah. So, and then for this purpose, we actually created our own customized data ingestion pipeline. The whole idea behind this pipeline was to just ingest data from various source systems. And currently, our pipeline actually can ingest data from Oracle, Sybase, SQL Server, most of the major SQL systems that we have, and that too within days. And there is not too much. It's, I think the way it's designed, practically anyone can actually take it and, convert it, use it to actually load data into Hadoop. The results, obviously, we are able to cut our time that it takes to load data from 7 to 8 hours to close to 2.5 hours. So we could actually load the entire data, which is much more than our traditional EDW, in like 2.5 hours. This was the main benefit. So as I mentioned, we were doing approximately 1,100 tables in Teradata, just because we couldn't, because of the time it took. We did all the tables from our EMR system, which was approximately 7,200 tables. And every night, we actually ingest data from 3,500 tables, all the incremental data that comes through various hospitals and clinics and all those places. And the entire pipeline was actually created using MapReduce in Java, and it was internally coded. As a part of this entire pipeline, what we did is we made different zones. The idea behind the zones was to satisfy various use cases that our users had. The first zone was basically the landing zone, where the ext files or the flat files would actually get dropped by source systems, or we would scoop the data and bring it onto our landing zone. The second zone, that the next step, what we did is we copied over the entire data from our landing zone into our raw zone. The files were compressed so we could save space. And then all the tables that were created on top of raw zone were basically all string types, and we didn't do any conversions or anything. The reason we wanted auditing capabilities, traceability, troubleshooting, just in case somebody comes back and says the data doesn't look good, we can just verify that whether it was a source system issue or the issue with our pipeline. The next zone that we copied over the data was to the refined zone. This is where all our MapReduce processing would happen. Basically, the idea was that this zone had temporal data, so it was an append-only zone. We had converted all the data types for the files to match with the source system, so that the dates were dates and the begins were begins, and et cetera, et cetera. And we did load it based on the partitions were created based on load dates, so that would let people only query the data that they would need rather than having to do the entire database. And also, some of the things that we made sure is we made sure that our pipeline actually made it as an ORC file. We made sure we use zlib as the compression technique, and we also added some Bloom filters so that the queries that run on those tables were faster compared to the raw zone. The current zone was basically the current snapshot of the data, so it would basically just define the most recent record, and it wouldn't have the history of the. And this was something that our users have been traditionally using it over a period of time, and we wanted to give them that functionality in a single location. And finally, the integrated zone. This is where we are actually building our customized purpose-built data sets, and we are also developing a enterprise data model right now, which would suffice various use cases, because traditionally what people or users at our place have been doing is writing customized SQLs and the same SQL over and over again in different departments, and we just wanted to get away from people having to write so much and save them time and do it in our integrated zone. So that's how we've created our various zones. I'm going to turn it over to Mark, and he's just going to talk about access and security.
So typically when we stood up a new platform, we would have it up and running in a development state, and then we would invite our information security office to come over and look at it and see what kind of issues they had. We would document it and then present it to compliance. But with Hadoop, we decided to do something different. We brought our ISO office in right at the beginning of the process. So they were in the early meetings with Hortonworks. They knew what the availability was, what type of options we had for encryption and so forth. And so we partnered with them, and they really appreciated that. And I just wanted to bring that up. They look at Hadoop at Geisinger as the gold standard for applications. So we're running a Kerberized cluster with SSL endpoint security. We do all our authentication through Active Directory and Ranger and Knox. And really, we're one of the, maybe the only or one of the very few applications that has all those safeguards in place. And we're pretty pleased with it. And I know the ISO office is pretty happy with how that worked out as well. From a Kerberos standpoint, we're actually doing what's called auth-conf, and that's confidentiality protection, which encrypts data in transit. So pretty much any security that we could put in place to protect the health information that we have, we utilized. And it's important because, at Geisinger, we have the largest collection of, health information in one place, as in Hadoop. So we want to make sure that it's properly secured.
So I think these are some of the projects which we are actually working on or we worked on in the big data space. The list is huge. I'm just going to go through a few, give you a brief overview of, what all things we've done in those. So, most of you guys, attended the keynote on Tuesday, and Dr. Schultz actually mentioned that 80% of the data in healthcare is unstructured data. And, that's true for us as well. With data being unstructured, it's very difficult to parse out meaningful information out of it. And there is so much useful information in there, it can actually be used to save patient lives and give them better patient care. So the idea was to jump into NLP, and we started it with the lung nodule initiative. The problem that we had on hand is, whenever somebody, let's say for example, would get into an accident or something and would go for a CT scan or CT scan, the providers would actually find incidental lung nodules, and those were actually in the patient notes, and we wanted to make sure that we actually get that information out and then get the necessary follow-up that the patient would need. The solution, we basically ingested all the radiology data, especially the imaging notes, and into Hadoop and ran NLP on top of it. The value, obviously, we were able to identify the lung nodules, give better patient care, and get people who needed the recommended follow-up come quickly and get their follow-ups. So this is basically the text analytics workflow that we have. Basically, what happens is the data from the radiology notes is sent to an NLP and dictionary annotator. And for this purpose, we are actually using the Apache CTEX pipeline, which is available open source, so anyone can actually use it. And we have about 100 plus dictionaries that we've integrated into our into our pipeline. So the idea would be the nodes would get annotated, and an XML cache is formed which has all the meaningful information, and everything is actually mapped to a UMLS concept code. From all these cache files, we would actually parse out only those nodes where a particular lung nodule was found. So that would be, I think we had approximately 10 million nodes, and out of them 9.7 million nodes did not actually satisfy our criteria, so we just filtered it out. The next 300,000 nodes that we actually identified as a potential lung nodule use case were actually passed through a negation annotator, which can actually say whether it was a positive reference of a lung nodule or a negative reference of a lung nodule. After the negation annotator, we actually ran some heuristics on top of that data to just parse out some meaningful information. Some of the information that we got out from it was the measurements, the location of the lung nodule, and then we would basically take that information out and calculate a RAD score in our heuristics. And that RAD score would help the providers to actually recommend a follow-up. It could be a 3-month, 6-month, or a year follow-up. So that's how we ran through our NLP CTEX use case for lung nodule. This is basically how typically a NLP performance is estimated, and we were able to see about 91% accuracy after we were able to parse out all these nodes. So that was definitely better than what we originally had. The other use case for NLP was our AAA use case, which was very similar. The idea was to find all the patients with AAA and get them in for follow-up. Again, very similar to the previous use case, we were able to ingest the data, use NLP on top of it, and then apply the care gap closure technologies on top of it. And we made sure that the users had the necessary follow-up done. And these were the results from our AAA use case. We were able to identify about 502 patients with having AAA, and then 23 of them actually required urgent surgery. So we had to call them and make sure that they got the necessary surgery. The other couple of use cases that we have is basically some of the dashboarding capabilities were not actually available, or people were not able to do retrospective analysis. And one of the things was to do retrospective analysis on the OR data. So what we did is we ingested the key data elements and metrics into a data model that we are creating, and then provided advanced visual and drill down capabilities. The couple of values that we got out of it was improved OR utilization. We could get more patients for surgeries, and we could give better care to our patients. And then the quality of care definitely improved based on the learnings from retrospective analysis. This is a screenshot of one of the tabs on the Tableau dashboard. It basically lets users do scheduled versus actual analysis, so they can actually know where the delays were and how many of the cases were actually delayed, and see the effect of one case basically delaying the entire day. The other thing that people can do is look at what staff was actually available in the OR on a particular day. So this helps them to know when are those days when they need more staff versus less staff, and all those questions that they might have. We've also given them various filters on top, which would let them slice and dice data in different ways. So it would make their life easier. So they don't have to come to us for each and every use case that they have. And we've guaranteed next day data availability. So any changes that they make on their end, if it's going to show them some results, they should be able to see it next day in the dashboard. Similarly, the other use case that we have is the check please use case. This was, again, for all the procedures that are done in OR. They wanted to understand what were the supply costs, how the variance was in terms of provider, in terms of service, and in terms of location. For this, we had to get data from our EMR, billing, and the supply chain system, and then we had to provide additional visual and drill down capabilities. The value, we were able to find where the greatest variance was, and also we had opportunities to manage costs wherever possible. The other things that we found which were useful was, we were able to find the best practices that people were following across platforms. We were able to isolate data issues. We were able to do cost optimization for our supply chain initiatives, and then definitely process improvements. This is a screenshot which actually shows a tab. This is where people can actually compare two procedures or they can actually compare the same procedure for 2 providers and see how they were doing. We've given them a ±1 standard deviation cost band, but it's customizable, so they can change it based on how they think is appropriate for their service line. And also, they can compare costs for same procedures by surgical role, because not necessary that a resident would be the same supply cost compared to a actual provider. This is a heat map based dashboard which we've given them, which basically lets them see the cost variance across all of Geisinger, or they can actually do it based on each service line as well. They can also filter it by lead procedures per case, and then they have drill down capabilities based on implants, explants, and they can actually do supply cost based on per procedure or per case. So these are some of the innovations that we've done in the last 1.5 years of our journey with Hadoop, and I think next few things are real-time analytics for us, as well as use cases for deep learning, which would be very beneficial to Geisinger. So before I go to questions, I just want to thank you guys for attending our session, and we'll be happy to take any questions. And the conference organizers would actually like you guys to rate our session on the app. So please, if you have a few minutes, if you can rate our app, that would be great. Thank you. Any questions? Yeah.
Just a statement. I'm glad that I attended this session.
She's coming around with a microphone.
It's good to know that there's a company which is there for 1.5 years only with Hadoop, and they're successful.
Yeah.
I mean, that's what I'm looking for this summit. So very encouraging to know that. So I want to actually understand a few things. Maybe first one question, and maybe later on. That for your key, LLAP, you mentioned that that which is very much performing well. Is it the only layer which is making those queries faster, or is it that in conjunction with the Solar search you have in place?
It's just LLAP by itself, and it's Hive SQL that we run through the LLAP engine.
So all of your Hive tables are partitioned, and are they like buckets or partitions? Is that all those queries are?
I think the refined zone that we have, which has temporal data, is mostly partitioned. The data in current zone is not really partitioned, but we made sure some basic performance tuning techniques have been applied, like ORC, zlib, Bloom filters, that would actually make our queries faster. So I mean, and definitely we made some changes in the backend, especially with LLAP, where we've given more cache, and then the container sizes. So I mean, with our PS engagement, we were easily able to make all those changes. They were able to recommend us changes, and that actually made the performance much faster. So we didn't have to make major changes to our existing process. That was the great part about LLAP.
And the queries are accessing the current zone. So the current zone is most similar to what we had in the EDW. So it's the most recent value for each column, basically.
Yeah, that's right. Yes.
Sure.
So are you now not using Teradata? So is that being retired?
It will be. That's our plan by the end of 2018.
I see.
So what we've done is, I don't know, we have maybe a dozen or so, large analytic groups. So we meet with them. We typically get some samples of the SQL that they run, and we parse that out and convert it to Hive. And then we meet with them, we review and document, show them the documentation on how, the nuances with Hive SQL. And then we provide, training and mentoring to them. And they're slowly moving their work over.
So you have, so just going back to what Dhruv was saying earlier, so you have Tableau sitting on top of Hive, executing Hive queries?
We do.
Yep.
And you said you have done tuning of Hive queries by partitioning, ORC, and what else did you say?
I think we've done things like ORC. ORC is the best format available right now, which is going to give us the best performance. So we make sure that our tables are ORC, and then we made sure we've added Bloom filters, which is one of the things a lot of people might get benefits if they are writing where clauses, where they are looking for specific departments. So based on the use cases, you can actually add Bloom filters to the tables. So some of the techniques which are highly recommended, and they are available on Hortonworks website as well, we've done those. We made sure that that would be beneficial for our users.
So one last question. So the general consensus is Hadoop's not yet ready for EDW, but you guys are, buckling the trend. So are you? Yeah. So are you saying? So would you recommend that EDW can now be replaced by Hadoop?
From the point that we're at right now, I think we're in good shape. Probably the most challenges that we have is workload monitoring, management. We don't have a huge concurrency of users yet in Hadoop, so I'm looking to see how that plays out. And we may have to do some additional tweaks to our Hive environment to make sure that there's concurrency and people get the resources that they need. But probably, the challenges that we had, can we load all the data that folks need? And we did that. And can we get similar performance without having users to do major rewrites of their queries and not having, our development team have to re-engineer the pipeline that we already built. And we were able to do that. So we're in pretty good shape. I'm sure there'll be some more bumps down the road, but LLAP I think was really the last piece that we needed to really feel comfortable with things. So I think we're in pretty good shape.
Okay, two questions.
Yes.
One is related to that. In order to retire EDW, what is your plan to migrate in the existing functionality over? And
Yes.
yeah, and how you can do that? The second question is that NLP, natural language processing, and it takes text analytics. Can you elaborate that in more detail? How do you do that, especially like medical terminology services, those kind of things?
Do you want to take the second one first?
Yeah. So I think what we did is there's an Apache CTEX project that's available, as an open source. We actually, took that and set that up on our Hadoop platform, and we were able to. What we had to do is we definitely had to write our custom dictionaries. We had to write our custom code, because what happens is, I'll just give you a sample example, right? Lung nodules, it's easy to find, but the problem is, sometimes provider mention ground glass opacities, which are very similar to lung nodules, and they are actually lung nodules. Now, some of those things were actually missing from the Apache CTEX libraries or the UMLS libraries that were available. So what we had to do is we definitely had to write our own dictionaries, own piece of code to actually handle. But I think the Apache CTEX pipeline actually helped us in a lot of the things that we wanted to do. So that made our life easier. Now, based on the use case, there are different things that we have to change over time, but I think that's gonna keep on happening. That's how it works, right? You always have to make some changes. Nothing out of the box comes customized based on your needs. So.
And from a conversion standpoint, we've stood up a couple of universes from business objects already on Hive, and they've worked fine. Tableau is a new offering, to entice users to move to Hadoop. And I talked about how we're migrating folks from a SQL standpoint. And if there's things that don't belong in Hadoop or there's some reason they're not going to work, we have a couple of other options outside of the traditional EDW to use.
3 quick questions. So you mentioned you started a year ago or more or less. So LLAP was not GA back then, right? It was still tech preview, maybe not even tech preview. So did you explore Hawk at all, or you are on Hive on Tez?
We did. We were really focused on Hive 1.2 at the point, and really looking at the use cases. We were building the dashboards and trying to get those early wins, and we knew that LLAP was coming. So we thought, before we look at another solution, let's see what LLAP can do. So we still have some challenges as far as what SQL can be done. The merge capabilities that just came out with the new release is a big plus. But our user community went through a migration from SQL Server to Teradata. So there was a lot of nuances there. So I think that they understand that they have to make some changes, but it hasn't been major changes yet. So if we get to a point where there's a large amount of SQL that's not going to run, then maybe we might have to look at something else. But at this point, we're not in that situation.
So you never used Hawk or any other?
No.
Okay. So 2 more quick questions. So for the ETL load, do you use something like Uzi for scheduling?
No, we have a enterprise scheduler which is called Tidal. So, and we've created our own customized pipeline which is all MapReduce based, so we can easily call it through one of the, through Tidal and actually run it. So we don't really have a need right now to actually use Oozie, because it's easier to use an enterprise scheduler, because as soon as the loads are done, we can easily kick off a Tableau job, or we can easily kick off a business objects report. That makes our life easier. So we've always chosen
The dependencies.
Tidal. Yep, that's right.
So what do you put in front of Solar? What UI? Is it?
Banana, which really isn't that great. We're trying to figure out maybe if we might have to build our own front end or see what other options there are. But it shows the capabilities of the tool, but I don't think it's probably a long-term solution that we want. But it gets people excited about Elasticsearch, and it does give some basic results. But ideally, we would want to get that initial result set and then allow people to do other restrictions on it, other funneling, and get to an even more smaller data set. Even with, we have about 4 million patients, and you think, oh, here's kind of an obscure thing, I won't get that large a return on it, you still get a pretty good sample. And so it's still a lot of data for our providers to go through.
Yeah, I think Solar was a good start with Banana, but I think as people start using it and they have more use cases, we'll probably have to look at other tools that can provide us a better graphic user interface for our users.
Thanks. What was the scheduler you mentioned?
Tidal.
Cisco.
Cisco. Yep.
Thanks.
Hi. So when you said you moved your traditional data warehouse from Teradata to Hadoop, so was that your traditional data warehouse was in a star schema, or is it how was it?
I think multiple. I think the data that we ingested directly from our source systems was a typical relational model, which was highly normalized. We had some use cases where there were star schemas and stuff, which we eventually are now converting it into our enterprise data model on Hadoop. But traditionally, our systems mostly have been ER based.
So, but now you're implementing a star schema on.
I think we have 2 layers.
Okay.
I think the first layer is basically a traditional, like a relational layer, but it's more like that would be, it's more customized for Hadoop. So, we've tried to make longitudinal tables as possible. The idea behind that actual zone or the integrated layer is basically to create a cleansed and very customized data set. And then on top of it, based on the use case, like for example, one of the things that we had worked on was BPCI, the Bundle Payments Initiative. That has its own star schema. So based on the use cases, we'll probably end up building multiple small star schemas or snowflake schemas.
Multiple data marts with a star schema.
Absolutely.
One of the challenges that we had is that our EHR data isn't perfect, but it's what the users have been using for years. And they're very accustomed to that data model. And so we almost have to offer that because they have a lot of historical analytics that they run against that. And then we, in the integrated layer, we provide those value-added data sets and the data model that Drew mentioned.
So how are you handling the data retention policy, which was earlier? Now you don't have to face that, right? You're bringing everything into your Hadoop.
Yes. Yes, I think so. A couple of things, right? We are definitely trying to get rid of Teradata, which is our plan for next year. And I think especially with our zones, right now we just load everything because we haven't reached a point where we need to start looking for archiving. But eventually we'll have to start archiving our data. So we'll probably, I think probably the logical next step for us is basically to do sort of a type 2 SCD. Type functionality so that people can see all the data from years. Right now everything is append only, so even if some data is not changed, there's a very good chance it might come as a changed record today. So those are some of the things that we have to work on next. So we are going to tackle all our challenges one by one. That's the plan.
Great job.
Thank you.
You guys said you were using HTTP 2.6.
Correct.
How long have you been using? How stable is it? And what version of it?
I'm sorry, the very last
How long have you been using and what version of it?
What did we start
What
with?
minor version of it?
2.4 or?
No.
Okay.
No, I'm talking about 2.6.
2.6.
Oh, 2.6?
I think we actually migrated to 2.6 as soon as it was GA probably within a week or two. We actually moved it to our development environment,
Yep.
and then within a couple of weeks, we actually moved it to our production environment. Yeah,
Yep.
it's pretty stable.
And,
yes.
and the upgrade, we went from 2.5.3 to 2.6.
Yep.
Went very smoothly.
Yeah.
Probably had a 30 node cluster done in about 2 hours. Yep.
All right, thank you so much.
Thank you.
Thank you.
Yeah.